really not much I need to introduce you with, do I? I'm actually working on a book called The History of .NET. Oddly enough, you're in it.
Cool.
So one of the stories I'll tell in that book is that you wrote the first version of ASP.NET in a month, right? By yourself in a closet?
Some of that's right, yeah.
Don't let the truth impair a good story. But I remember going to an SDR. I think it must have been 99 or 2000. And
Yeah.
you were terribly young.
Yes.
And talking about this ASP Plus thing. And you were finally going to fix active server pages because it was only so good.
I think the first prototype of ASP.NET started November of 1997.
Yep.
So we're coming up on the 20th anniversary of the first prototype that I wrote. So
Yeah. We'll have to throw a party.
Cool. Sounds
I think
good.
it's next month, actually.
Okay. Well, then we'll go for it.
Folks, Executive Vice President Scott Guthrie.
Cool. Well, good morning, and thank you for coming out bright and early in Las Vegas at 8:30 to come hear me talk. And I'm really looking forward to the next sort of 75 minutes or so, where I was going to basically do a brief introduction to Azure, and then really dive deep and really build a couple of different apps and show off some of the cool services that we as developers can now take advantage of, and hopefully highlight a bunch of the cool new technologies that you can take advantage of because of the cloud. You know, I think, one of the things I always say, and my clicker is not working, whoever's backstage. Oh, there we go. It's working now. Great. One of the things I always say is, at events like this, is it's a great time to be a developer. And, I think that's true more than ever. When you think about all the different technology that we get to take advantage of, whether it's, new things like containers or serverless computing, whether it's new ways to build apps that involve IoT or augmented reality, whether it's new ways to store data like NoSQL in addition to relational, whether it's like graph and other data formats, and whether it's new practices like DevOps. There's never been, I can remember at least in this industry, more things to take advantage of and more cool technologies that are coming out than they are right now. And in large part, a lot of these are coming because of the cloud. At the same time, one of the things that I often hear at events like this is, this is all great, and it's both exciting to be able to take advantage of all this, but the reality is also it's a little overwhelming. And how do you stay up to date with all the latest technology? How do you deliver solutions that sometimes aren't just sort of the next of something that your company needs, but a brand new way for them to really engage with customers, drive revenue, reinvent the business? And how do you stay up to date with all this cool stuff, build brand new experiences, and at the same time, how do you make sure you're not going to get hacked? And right now, I think we all kind of live in a world where security is paramount and where the threat environment is super high. And needless to say, all these things are not super easy. And one of the things that we really focus on at my team, both in terms of Azure and the cloud platform that we build, as well as things like Visual Studio and our overall set of tools and products that we deliver, is how do we hopefully provide a cloud and a set of development technologies that enable you to take advantage of all this bleeding edge capability, allow you to build any type of app, and do it in a way where you can be super productive, where you can basically build solutions that are hybrid, that can run both 100% in the cloud, or more likely integrate with existing things that you already have built and run in your existing data centers, that can integrate AI and take advantage of intelligence to be even smarter in terms of how they operate. And then last but not least, how do you do it in such a way that it can be secure and that you can bet your business in a trusted way on top of the solutions that are built? In a nutshell, that's sort of what we're trying to do with Azure. And hopefully you'll see reflected throughout the demos that I'll do today. And I'm going to spend most of the time in demos. These four attributes kind of infused across all the different services and capabilities that we offer. And so what I thought I'd do is, rather than just sort of wax on about all these different attributes, is actually just switch over and we'll go to demo machine A and actually show off some demos of what this looks like in action to try to make it a little bit more real. And again, you'll see this hopefully reflected throughout all the demos throughout today. So how many people here are using Azure today? Okay, a number of people have. How many people here are using other cloud providers today? Right? How many people have never used the cloud? How many people are here thinking they're going to a Garth Brooks concert? Anyway, okay, we'll start singing soon. So what I thought I'd do is just give you a quick introduction, since it looks like maybe 25% of the hands went up for people that have used Azure before, of just sort of what is Azure, and kind of orient you a little bit around our management portal, which is something that if you're new to Azure, you'll get familiar with, because it's sort of how you create and manage things. And so this is our management portal. You can kind of browse resources by different types. So if I want to see all my virtual machines, I can click the little virtual machines tab on the left. If I want to create new things, I just click the new button. And this basically gives me an option to create different types of resources, both VMs as well as higher level developer services. And then I can also do what's called pinning resources to the dashboard, which gives me kind of a quick way that I can jump into a particular resource if I want to manage it. And it also allows me to pin dashboard items, so I can do monitoring. In this case here, I have an application map in the top right showing me the health of my application that I can, again, very quickly monitor and see, all through the browser when I log in. And all our resources inside Azure follow kind of a fairly consistent model, where we have kind of details here about the particular resource. We provide a bunch of built-in monitoring views, and on the left-hand side, we provide lots of standard things. So in this case here, this is a VM, and so if I want to control the networking ports and what's open and closed, I can just click networking and see it. If I want to attach disks, I click disks, and so forth. And one of the things that's kind of nice about Azure is I can manage all this through the GUI. I can also manage it from the command line. I can also manage it through code. And so I can actually take a .NET, Java, Node SDK, any language, and programmatically control and manage all my resources as well. And what's powerful about Azure is, and we'll show a video of it in just a bit, of just in terms of the infrastructure you can now take advantage of literally within seconds. Sort of changes the game in terms of how you build applications and what you can kind of build. So a quick question in terms of the room here. What's the biggest machine that you've ever worked with? Not all at once. Anyone here worked on a system with a terabyte of RAM? Right, you got a couple hands, 2 terabytes. Ooh, that's 3 terabytes. Got you beat. Can anyone beat 3 terabytes? Well, with Azure, you can basically create VMs that are up to 19 terabytes now and have up to 750 CPU cores, which is a big machine. And you don't typically use that, but we have lots of customers that are using it now for large SAP workloads where they're running their entire ERP stack. We also have lots of smaller machines. They start with a gigabyte. What I thought here I'd just show this kind of cool machine is a more typical machine that you can spin up, and if you're afraid of spending too much money, you can spin it up really quick and then turn it off and only pay nothing. But this is sort of what we call our M-series VM, and so this is 128 CPUs, cores, and 3.5 terabytes of RAM. And so the cool thing is, when you go into Azure, you can literally just say new VM, pick the size. 2 minutes later, you can basically log into this, like I am right now, and basically manage this and all these resources. And so let's actually look inside here. And so this is 128 CPU cores basically doing nothing. But how often do you get to see a view like that? So that's kind of cool. The other thing that's kind of neat about Azure now is pretty much all of our new virtual machine types support both hyper-threading and nested virtualization. And nested virtualization is kind of a unique thing in the cloud, and it gives you kind of even more flexibility. And no other cloud provider currently offers it. And so this 3.5 terabyte VM is actually running its own virtualization stack inside the VM, and it has 2 sub-VMs inside the VM inside Azure. And in fact, if I go ahead and one's Linux and one's Windows, and if I go ahead and click it, I can even remote into the VM that's inside the VM that's inside Azure. And you'll see inside this one here, I've got another VM. And so if I want to go kind of infinitely deep, and this is an Ubuntu VM, I can basically, and so here is a Linux VM running inside another VM, which is running inside another VM inside Azure. And so if we wanted to, we could spend the whole keynote just infinitely going deep, double-clicking inside VMs, sort of Inception-like, but that'd be like a dream. So anyway, we'll skip that. But it gives you kind of a sense of the type of power that you can take advantage of. And the beauty is when you don't need that power, you just click the stop button and it'll stop, and you pay only for the seconds that you're using these particular resources. So it ends up being super cost effective and giving you kind of a lot of agility in terms of how you manage it. Other things that we try to do inside Azure to kind of help is not just give you lots of power, but also kind of provide sort of these end-to-end scenarios. And you'll see this reflected a lot when we start writing some code, and we'll do it in a variety of different languages. How do we enable you to quickly spin up an environment and have a load balancer and have continuous integration set up? How do we take care of backups for databases and others? And that's sort of an example of how we're trying to be as productive as possible and really give you an experience that enables you to focus on what you want to focus on, which is building apps, and not have to spend all your time stitching things together to make them work. And we try to do that even all the way to infrastructure. So let me open up another VM before we start writing code, just again to show off some of the other capabilities that we try to focus on the end-to-end side. And so, as I showed earlier, I can control network ports inside Azure, I can do disks, I can do drives, I can change the size of the VM, all the stuff you'd expect. The other thing you can now do, which is kind of cool, is you can also scroll down here, and now we have a bunch of operations that you can also now do that we've integrated directly into all the VMs that you host inside Azure, both Windows and Linux ones, that give you additional kind of management tasks that other cloud providers don't deliver. So for example, if you ever want to know, are my systems patched? All you need to do is just click Update Management. And this is actually talking now to an agent running inside the virtual machine and scanning this VM to see whether or not all the OS and system patches have been applied. And you can see here I'm missing 2 updates that I need to apply. And I can basically go ahead directly here and schedule an update inside my VMs. I can also manage across multiple computers. And so here now I'm going to actually scan across, I think it's 20 or 40 different VMs. And so it's real time querying those VMs. In fact, now it's 58 VMs. And you can see 25 of them right now are actually out of compliance, meaning I'm missing critical system updates. And what I should see here in just a second, once it finishes querying all of them, is literally every single one of the updates that I'm missing, which machine is missing what, and what do I need to basically install to take advantage of. And what's nice about this is I can do it both with Azure VMs that are running inside Azure, as well as you can see I can add non-Azure VMs into this environment as well. And so for example, if I have existing systems that are running on premises, say in a VMware environment, or if I am even using a different cloud provider, I can go ahead and add them as well into this environment and basically now have a unified way to view across all my patch systems, or all my systems, what's patched and not patched. And so if you zoom in here, you can basically see all the different types of VMs, whether it's compliant or not. This one's running in Azure, it's a Linux VM. This one's running in Azure, it's a Windows VM. And if I scroll down here, here's another VM that is not running in Azure, that's running Windows. And again, I can see a unified view across sort of that entire environment to understand whether I'm up to date and whether I'm current. Other things that we have built in, as another example, would be things like inventory management. How many times have you ever wondered, is this component installed on a server as you're deploying your app and it doesn't work? Sometimes. Or maybe across a fleet of servers. And so this thing here is called inventory management. This is actually, again, scanning my environment in real time and showing me every single component that's running across all these different systems. And so I can see, for example, is IIS installed? What version? Is ASP.NET installed? What version? And we do it also for Linux as well. And so if I want to know, for example, where is, say, the app tools installed, I can go ahead and search, and you can see basically I have App Daily and App Daily Upgrade are the 2 Linux daemons. They're stopped on this particular VM. And I can understand and then even drill in who stopped them, when did they get installed, what version are they, and be able to take any activities from it. And again, be able to do that across all the infrastructure that I manage and take advantage of as I'm building my apps in the cloud. Now, all the things that we do, things like change tracking is a cool feature. If you've ever wondered why something stopped, you can click on change tracking, and it'll even tell you down to the registry or file or Linux config file, who changed it, what changed, and you can basically see in real time, again, everything that's been modified, and so forth. And so, again, lots of built-in stuff that you can take advantage of. And all these things, obviously, you could script and do yourself today in a variety of different ways. We're trying to build it into the experience and give you something basically out of the box that you can just take advantage of and use. Last thing I'll just mention while we're on this VM is disaster recovery. I think one of the things, obviously, that everyone's seen over the last 2 or 3 months is, the impact that nature can have on the world, whether it's around fires, whether it's hurricanes, whether it's flooding. And traditionally today, building apps and infrastructure and having it be resilient to those types of natural disasters is really hard. And most organizations have a single data center or a small set of data centers and run the apps only to work inside those. And again, one of the things that we try to do is make that easier. And built in inside every VM now is DR support. And so you can now pick across any of the Azure regions around the world and configure your apps and your VMs to basically be replicated and or DR ready in another region. Basically just configure it, and then you can even test DR without having to fail over to make sure it works. And then anytime you see a storm coming or you see a natural disaster, you can press a button and fail over your systems literally anywhere in the world and maintain your business operations. But again, just an example of something that is built in that you can take advantage of and use. So we've looked at a bunch of sort of examples inside VMs. We're going to look at a lot of other services in just a little bit as we go deeper into the keynote. But again, hopefully you're starting to see kind of when I talk about productive, what we're trying to do and try to integrate that as part of the experience. How many people here like to use command line? A number of people do, great. Good news is all this stuff we're talking about productive, you can take advantage of from the command line as well. We have both Bash as well as PowerShell support inside Azure for everything I just did through the UI. And we also have something called the Cloud Shell, which is in the top right. And basically, if you click this, it launches this little window here directly inside the admin portal and actually boots up a Bash shell or a PowerShell, depending on what you've configured it for, directly inside your browser experience. And so this way, you don't even have to download your command line tools locally. You can do everything literally directly inside the browser. And what it's doing behind the scenes here is actually spinning up a VM inside Azure that it's going to host this Bash shell within. It's a VM that we manage and provide for you. It's free. And now, for example, here you can see I've got a full in this case here, Bash VM. I could toggle it and go into PowerShell mode if I want to use PowerShell instead, directly inside my browser. This is a real Linux environment. So if I want to do, for example, PS all, I can see all the processes running inside it. If I want to use Vim, I can literally actually now launch Vim inside the Azure Management Portal. And so I could write help, I can't get out. Those of you who don't know Vim. Apparently I don't. There we go. And then we also have a built-in set of tools. You type AZ, which basically gives you kind of what we call the Azure CLI experience. And this basically gives you a set of commands that you can operate across everything that you want to do in Azure. And so here, if I wanted to see all my virtual machines, I could go ahead and just say AZ VM list. I could output it in JSON or a comma-separated format, or in this case here, I'm just going to output it as a table. And again, everything you can do through the GUI, I can now go ahead and also do from the command line. Again, whether it's Bash on Linux, whether it's Bash and it's on a Mac or PC, or whether it's PowerShell on a PC, or because PowerShell now runs also on Linux and a Mac, you can actually run PowerShell from whatever environment and tool of choice that you have. And then last but not least, the other thing we try to integrate is monitoring. And so monitoring is kind of built in throughout the system so that you can basically track how your resources are doing. You can see right there that one of my data factory jobs just had an issue. That's not an Azure issue, that's actually a problem with the job. But it's sort of alerting is also built in directly to the system. This is a view here, just so you can see a little bit better. Let me resize this. Of what we call an application map. And this basically gives you a way you can pin any application that you want the monitoring of its resources directly on your dashboard. And so, this is sort of an example, again, of some of the built-in monitoring capabilities. And so if you view inside here, one of the things you'll notice in this built-in monitoring view right now is my app is having a problem. And it's deliberate because I want to show off the monitoring. But you can see here my availability is below what I'd like it to be. So it is currently at 96.8%. If I want to understand what's going on here, I could basically drill in and actually look at the slow requests that are operating through it, any failed exceptions that are occurring, and then directly inside the experience, it's pulling up all the diagnostic details about this particular application, how many requests, what dependencies it has. And then if I need to or want to, I can go ahead and look at all the failed operations that are failing. And so I have this particular method call that's having an issue. Here's a bunch of the individual requests that have failed. And I can drill into any of these directly inside the experience, see how long it took, 43 seconds before it failed. That's pretty bad. And if I want to understand what's going on, I can even, say if this was .NET, pull up the exception stack trace information. It also works for Java, for Node, and all the other languages as well. And I can actually see detailed information about what the exception was, and then more importantly, who called it, from what client where. And so I get all that detail kind of in real time, directly plugged into my management experience. So I can not only build apps and manage their settings, but I can actually monitor how they actually operate. And then we've even integrated with things like our Visual Studio Team Services, which I'll talk about a little bit later, so that if I want to, I can go directly from Azure, create a bug in my bug tracking database with all the telemetry information, all the configuration information about this particular exception, and assign it to a developer who can go ahead and fix it and then check in a new update. Again, all integrated, kind of all fairly smoothly inside the system. And hopefully the end result is I end up being much more productive in what I'm doing. So I could go on and show off the experience a lot more, but I just wanted to kind of start a little bit in terms of when I say productive, what do we mean by productive? And when we say hybrid, what do we mean by hybrid? And hopefully you saw throughout here, I can basically take advantage of all this rich experience to move things much, much faster. And with the hybrid capabilities, I can do it both for apps that are running inside Azure as well as on premises. So if we go back to the slides now, let's talk about some more things that we have, and then we'll dive in and actually write some code and do some more demos. So, where does Azure run? So Azure runs all over the world, and it's a cloud computing platform. And we have 42 what we call geographic regions now around the world, which are data centers where you can basically deploy and run the code and the applications that you build. We have more regions now than any other cloud provider. In fact, we have more than Amazon and Google combined. And this gives you kind of the ability to build systems that literally run everywhere and take advantage of amazing capacity. I showed you that VM there that has 128 CPU cores and 4 terabytes of RAM. You can use and scale up in any of these regions, or you can scale out across all of them. What I thought I'd do is just show a quick video of what one of these regions looks like on the inside to give you also a sense of the scale and the type of capacity that you can now all take advantage of. So we're going to go ahead and roll the video. And one of the things that we do with all of our services inside Azure is make sure that obviously we run them securely, but also that we provide trust certifications and independent audits that you can leverage so that you can also build secure applications that can target any industry. And so this slide here just basically shows off some of the certifications that we have today. We have more certifications than any other cloud provider. And so whether you're targeting, for example, healthcare and you need to be HIPAA compliant, or you're doing financial transactions and you need to be PCI compliant, or you're in the pharmaceutical space and you need to be FDA compliant, we have all those and more. We also have the highest levels of the U.S. Department of Defense, which is DISA Level 5, as well as even the intelligence services now. So you can literally build applications that can literally target any customer here in the U.S. or elsewhere around the world, and basically be able to really take advantage of this for everything. And the combination of all the services that we're going to talk about and the global scale and the trust is leading to tremendous adoption of Azure right now. We have about 90% of the Fortune 500 companies are now deployed on top of Azure and running systems. This slide just has some logos of a few of them. I thought I'd play one more video before we dive into the code of just a couple of customers talking about their experiences and what they're doing with it.
Microsoft Azure gives us key cloud-based infrastructure that we need. We made a big decision to break down our existing platform, which was one big, large, monolithic lump of software, into a microservice architecture.
This Black Friday, we served 167 million requests in the 24 hours. Average page response times came down by about half a second. That's what you're looking for in a new platform.
We moved to a platform as a service model. We can roll out changes to any region and environment very quickly, and also provision new environments much faster.
It really allowed us to focus on just shipping code.
We are using Azure Functions now in some components of our ordering system.
We only pay for that data that we and those functions that we do use. And we know that Azure is always going to be at the cutting edge of any cloud technology.
We wanted to make it really easy for our customers to get meaning out of their data. The industrial Internet of Things is different only in the fact that our customers have very stringent requirements about how data moves. We want one place to egress that data that we can lock down. The advantage of it being Azure is IoT Hubs makes it very easy to get that data in. Power BI makes it very easy to visualize that data once it's there.
It allows us to put a data scientist in a box.
Microsoft helped us achieve our digital transformation. It's put us over the top. Geico's been growing leaps and bounds, and we have not had any issues whatsoever from a capacity perspective because of the on-demand capability and scalability of Azure. We can handle the volume. We're like, bring it on. We want more.
So what I'm going to do now is kind of dive into some of the richer, higher level services in terms of Azure. We looked briefly at infrastructure and VMs, but the power of Azure is that you don't have to kind of work directly on a VM. You can if you need to or want to. But instead, you can actually take advantage of higher level services, things like container services or app services that let you host your web apps, or databases as a service that provide both relational and non-SQL database services that, again, you can leverage as developers to be more productive and do better things. So let's go ahead and start by talking about one of the most common services we have in Azure. We call it Azure App Service. And this is often the best way, if you're a developer who has never used Azure, to get started and really start taking advantage of what the cloud has to offer. And so with Azure App Service, we basically provide a way that you can very easily take any type of app, whether it's a .NET app, a Node app, a Java app, a Python app, a Ruby app, or a Go app, and deploy and run it inside the cloud. And what's nice about App Service is you don't have to worry about patching VMs, you don't have to configure load balancers or web servers directly. Instead, it provides all that environment for you so that you can really focus on just writing your app and your code and let the cloud really take advantage of everything else. And it also now gives you an option where you can deploy apps both inside a Linux as well as a Windows environment. So if you're a .NET developer, you can target Windows and run it in the same OS that you'd run on premises. If you say you're a Node developer or you're a Ruby developer, you can deploy it and get all these capabilities inside a Linux environment and know, again, that you can call all the standard libraries that your particular language might expect to be installed on the system. And then we also provide auto scaling continuous integration support, and a whole bunch more. So what I do is let's go ahead and show off a demo of this in action. How many people here are developing with, say, .NET and Visual Studio? Okay. How many people here are developing with Node? A couple of hands. Python. A few hands. Ruby. Go Ruby. Go. PHP. Okay. The cool thing is we got support for all those. So what I do is actually, why don't we, just to mix it up a little bit, since we did a last demo on a PC, let's actually switch to machine B here, which is my Mac, and let's actually build our first Hello World app using something other than .NET, and then we'll switch over to Visual Studio and show it inside .NET as well. And so what I'm going to do here is just, I've logged into the same management portal here that you saw before, this time though on my Mac, and I'm going to go ahead and create a new web app. And so to do that, I'm going to go ahead and just say new, and I'm going to pick this web app option. This is where I need your help. What would you like to call this web app? What, sorry? Strip on Vegas. How about we do something, how about we say morning in Vegas? And so I'm just going to go ahead and create this app. I'll call it Morning in Vegas. I'm going to choose to run it in the US. I'm going to do what's called pinning it to the dashboard so we can find it easier. And I'm going to go ahead and hit create. And so what this is going to do now is it's basically told Azure, please go ahead and create a new app service for me to use with a web app that has a Morning in Vegas DNS entry. And it's going to basically stand up a set of backend VMs that Azure is going to manage for me. So again, I don't have to do patching or anything like that I can deploy my code into. It's wired up the load balancer that's going to be in front of it, so I can auto-scale up those VMs and auto-scale them down if I need to. And as you can see here, in just about 30 seconds, I now have an environment configured that I can go ahead and use to basically build and deploy an app. Now, the first problem, though, is I forgot, we haven't built an app yet. So let's go build the app. And so I'm just going to go back to my Mac here, and we'll go ahead and we'll create this Morning in Vegas app. So I'm just going to create a directory, Morning in Vegas. There's nothing in the directory right now, so let's go ahead and just add a server.js file, since this is a Node app. Again, I could use any language I want. And I'm just going to paste in a little Hello World Node app that literally just says Hello World, and hit save. And if I go back now, just to test this out locally, I'm just going to say node server.js. I've spun up now that application, and if I go localhost 8000, I got Hello World back. So again, simple Hello World app running locally. I've got an app service environment created in the cloud. Let's go ahead now and publish this Hello World app up into Azure. And so to do that, I'm going to basically go back into Azure here and into this app service. And I'm going to pick this option here on the left-hand side called Deployment Options. And so basically within Azure, we have a couple different ways I can deploy code to an app service. I could just FTP up the code, or I could push it with source control. And so we support the ability to git push and deploy apps. I can also point to GitHub repos or Visual Studio Team Service repos that I already have. In this case here, I'm just going to set up a local Git repository for my app. This just configured it. I can then go ahead and you'll notice I now have a git clone URL on the right-hand side. I'm just going to copy that to the clipboard. And now to deploy my app, I'm just going to go back locally. And I'm going to say git init to initialize Git inside this directory. I'm going to add this Node.js file. I'm going to go ahead and commit this and say this is my initial check-in of code. And then I'm just going to say git remote add Azure and paste in that URL to my remote site. And this is basically just wiring up a remote that we're going to call Azure that points to my resources in the cloud. And I can now just say git push Azure master, like so, if I spell it right. And this will ask for my password on Azure once. And now what I should see is this is now pushing up the code into that app service environment that's running inside the cloud. And if I come back here now and hit this Morning in Vegas URL, that Hello World app that was previously only running on my local system is now deployed and running in a brand new app service environment hosted entirely inside Azure. And that's literally how easy it is to basically take an app and basically, in this case here, a Node.js app, and run and deploy it up there in the cloud. Now, if I want to make a change, I can obviously go back. I could say, hello, Vegas, or how about good morning, Vegas? Like so. Go back here. I'm just going to go ahead and add that in, make another commit, and just say updated text. I'll just get git push Azure Master. This deploys it. I can hit refresh. And now it says good morning, Vegas. Again, this is now updated and deployed inside the cloud. And you sort of get a simple example of how easy it is to deploy an app, update it, and basically start taking advantage of what the cloud has to offer. Now, the other thing I'll just quickly mention here that's kind of cool is now that I have an app that's actually running, I can also do, I can also do certain operations. So for example, if I want to scale up this application so that it can run on larger sets of resources, I can go ahead and click this scale up app, or I can scale it out. And since it's a web app, I'm going to actually choose the scale out option. And with the scale out option, what I can basically do is very easily control the number of VMs that this app is running on. So right now it's running on 1 VM. If I want to run on 8 VMs, I could just go ahead and plug in 8. And this will now scale out the app automatically with the load balancer already wired up for me. And I now have 8 times the resources to run this app. The other thing I can also go ahead and do, though, is just go ahead and create what's called a scale condition instead. And so instead of having a fixed number of resources, I can configure it. So say, for example, I have between 1 and 10 VMs that I might be running. And I could basically add a rule which says automatically monitor the CPU performance of my virtual machine. And if my CPU goes above 70%, start adding virtual machines until it brings it back into a normal range. And if my CPU ever goes below 20%, start turning off virtual machines until I get down to 1. This gives me a way that rather than have to have a manual number of resources using, I can auto scale up and I can auto scale down based on exactly what my app needs, saves me money, and make sure that I have a great customer experience. The beauty about all this is I literally just type it in, hit save, and in about 10 seconds, this rule is now applied and now in operation on top of the system that I've deployed. So super easy way to deploy, super easy way to enable things like auto scaling, all built in, again, using whatever language of choice that you want to take advantage of as you start building your apps. So let's switch back now to the PC and do a similar thing, in this case here using .NET, since we have a lot of .NET developers here. And so what I've done here is I've just done File New Project inside Visual Studio. So I have a default ASP.NET MVC application. And if I want to publish it to the cloud, I can just go ahead and right-click Publish. This brings up a nice integrated experience inside VS. I can either create a new app or I can select from an existing app that I've already got, just so you don't have to watch me re-enter and recreate a new app. I'm just going to use an existing one. This is now browsing all the resources that are running inside Azure. And so you can see here, I can just go ahead and if I want to deploy this to this existing .NET app, zoom in so you can see it. That's right here. I can just select it from that list, hit publish, and this is now going ahead and deploying this application up directly inside Visual Studio. And once it's done, it'll launch a browser, and in about 5, 4, 3, 2, 1, there we go. I was off by a second. It's now deployed and live inside the cloud. Someone thought it was good. Okay, good. And if we want to do it again, again, we could say, hello, Vegas. And just redeploy it. Now it's only going to change the incremental differences. And so it'll publish even faster. And again, in about 4, 3, 2, 1, I got a new version of the app that's up and running. So super easy way to do publishing, again, regardless of what your development environment is of choice. and take advantage of it. Now, how many people here have ever deployed an app into production that had a bug? Few people. Look at those people. Scowl at them. No. There's a few honest people, at least here in the audience. Let's talk about, in case you have friends that have done that before, how we can go ahead and help solve that problem. So this is that Hello Vegas that we have now deployed inside our app environment. And let's go ahead and make a change to that Hello Vegas. And so I can go back into Visual Studio here. I go say Hello Vegas, and we'll just say updated code maybe. Updated v2. And obviously I could just republish it straight into production if I wanted to, like you saw me do with that previous version. The downside though is what if there's a bug? And then I'm just going to basically blast this machine, this update out to everyone that's visiting the app or the site. And that's where there's another couple cool features built into Azure that help a lot. And that's called deployment slots. And so what I'm going to do here now is open up this application inside the Azure portal. And I'm going to create what's called a deployment slot that I can alternatively deploy this application into. And so the way a deployment slot works, it's pretty easy. You just click the deployment slots button here, and you can add what's called a slot. And so I'm going to basically just call this slot staging. And we'll call it staging Vegas. I get whatever name I want. I can embed the version string if I wanted to inside it. And, and again, in about 5 seconds or so, I now have what's called a staging slot that's been added for this application. And once I have that now, when I go ahead and deploy my application, rather than deploy it always into production where every user will see it, I can instead create what's called a new publishing profile. Give me that list of apps again that you saw me use earlier. And when I deploy this now, the difference is instead of deploying it directly into the main app, I'm going to deploy it into a staging slot instead. And so I could deploy into that Vegas staging slot. In this case here, I'm just going to click staging. And then I just hit publish. And what this is doing now is basically with that staging slot, it's set up a private URL to my application that only I know about, and that I can basically use to test this application before everyone in the world sees access to it. And so now we've just republished the application. Again, you'll see it's now live, but if you look at the URL, you can see up here that it is scottgusa.net-staging instead of the primary URL. And if I go back to the main URL that all my users are using right now, which has no -staging in it, and hit refresh, you'll see it still has the older version of the application. So this gives me a way I can basically deploy my code changes up. I can do all my last-minute testing in the real production environment and know that no other user is going to see this version of the app until I finally sign off on the app in production and I'm ready for our external users to see it. And when they do want to see it, or when I'm sure that they're ready, I can just go back here and hit swap inside the portal. And I can basically say, let's swap between our staging version and our production version. Click OK. This is basically initiated what's called a swap command. And Azure's now modifying the load balancer to point all new users at the new version of the app. And if I go back now, you'll see on the main version of the app, what used to be Hello Vegas, if I hit refresh, it's now been updated to v2. And so now I've atomically deployed the updates. And what's cool is the staging slot, if I hit refresh, has the old version of the app now in it. And so if, after I've gone live, I do find something that went wrong, I can go back to the portal, swap back, and automatically in about 3 seconds roll back to the previous version of the app without having to redeploy anything and basically get to a known good state very, very quickly as part of my application process. So again, nice simple feature, but one that can kind of dramatically simplify deployment and give you that ability to kind of quickly roll back whenever you find an issue and do last-minute testing in production before you throw all your users at it. And again, something that's nicely built in, you can create, I think, something like 500 different deployment slots per application inside App Service. It's free, and so you can basically take advantage of it in a really easy way, again, to optimize your workflow and make it better. So let's go back now to the slides, talk about a few other things that you can take advantage of with Azure. One of the cool things that I think is a sort of buzzword that probably many of you have heard now in the industry recently is something called serverless-based computing. How many people have heard of serverless? Great. How many people here are using serverless today? Okay, a number of people are. And basically the idea with serverless is instead of having to have, for an app like say a web app, this app service is great because typically you're having lots of web requests that are coming all the time, and so you have some environment that's typically always running if it has any volume of users hitting the app. But there's other scenarios where you don't actually have as frequent an access pattern, and you might not want to have a VM that's running that might be sitting somewhat idle a lot of the time. And the beauty about serverless code is instead of having to have a VM or a container or an app service running all the time, you can instead just instantiate it when you want to run code in response to a trigger that happens inside the application or the environment. And that trigger could be an HTTP request. It could be a timer. It could be a response to a storage file change. It could be an IoT event or any number of other things. And the beauty about Azure, we now make it easy for you to take code, again, written in whatever language you want, and very easily deploy it in a serverless-based way and wire it up to trigger only in response to these types of events. And one of the services that we have that enable you to do this is something we call Azure Functions. And it provides a great experience where you can develop it both in the browser, you can develop it directly inside Visual Studio, and we also now have great tooling that works cross-platform on any device with VS Code, and then you can also just do it directly from the command line. So let's go ahead and actually flip back to machine A again and actually show off some functions demos here. So I'm going to launch here a function app inside the Azure portal. To create a new function app, you just click New Azure Function, and you can give it a name and deploy it. This is one that I created for some demos earlier. It's actually running in Europe, so when we run it, there'll be an extra second or two as we bounce back and forth between Europe. But it gives you kind of a nice way to get started and take advantage of serverless computing. And to start off with, rather than use Visual Studio, I'm just going to do it directly in the browser, since it's often the easiest way to get started with functions. And then we'll show a richer example that's built using a VS project in just a few minutes. So to create a function inside Azure that's serverless, it's pretty easy. I just click the New button once I create this function. And I can choose from a number of different templates. So I could, for example, have a template that executes code, or C# code, or JavaScript code whenever an HTTP request comes into my application. It's probably the easiest way to get going. And so I'm just going to go ahead and select this template. I can then go ahead and name it. And so what would you like to call the serverless function? More silence in Vegas. We'll go ahead and create it. And this browser-based experience, again, it's designed, you don't have to have any tool at all. It gives you a nice code editing experience that you can use directly inside the Azure Management Portal. And this sort of simple hello world is just a static function. So it's not a class, it's not a whole assembly. It literally is just a method. And it just has some inline C# code here that pulls a parameter off the query string and spits it back. So simple hello world here. Now to run this, just go ahead and hit run. And this basically gives me kind of a nice logging environment down here. And if I want to, I can just get the function URL, copy it to the clipboard, and then if I go here and hit enter, you'll notice it passes back a message that says, please pass the name in the query string. So I'll say, okay, let's do that. And I'll just say, and name equals Vegas. And you'll see that I get a hello Vegas string back from my function. And the cool part of this is I'm not spinning up any container, I'm not spinning up any VM. This code is only executing when an HTTP request comes into that URL. It executes for a few milliseconds and then it disappears. And you only pay for the millisecond of code execution that you're actually running. And so that ends up being incredibly cost effective if you've got something that's going to run infrequently or doesn't require a ton of different compute to run. As an example, we've got one of our large customers in the manufacturing space is using Azure Functions with an IoT pipeline, and they send over 1 billion IoT function requests to their function app. And they called us up after the first month and said, the bill says it's only $70. There must be a bug in your billing system. And we went, there must be a bug in the billing system, and we checked. And then what we discovered was it actually wasn't a bug in the billing system. It really was only $70 to basically execute 1 billion requests with functions. And they went, yay, we went, but it gives you kind of sort of the power of the economics that serverless starts to bring. Because you're again only paying for those milliseconds of usage that you're doing. And I could test out more. There's a nice sort of on the right-hand side here, you can see you can add parameters and headers, so you can kind of do kind of more HTTP testing without having to have Fiddler or a separate tool. What's cool about functions, though, is it doesn't just work with HTTP requests. I can trigger a function response to sort of anything. And I can also integrate from HTTP requests from other sites as well. So how many people here use GitHub? A lot of people do. How many people here have wired up a webhook in GitHub? Well, only a few. So let's do something fun. Let's go ahead and create a new GitHub webhook. And basically, when you create a new function inside Azure, you can create a webhook template. And we have a generic webhook template, which allows you to basically wire up a callback from any service. And then we also even have like a GitHub specific template that we pre-populated that has some of the GitHub semantics already embedded inside it. And again, you can choose whatever language. In this case here, I got, I think, F# highlighted to build it. And so here's an example of what a GitHub webhook might look like. And this is what our default template does. It's, again, it's 6 lines of code. And it's basically just pulling out a value that GitHub sends in response to a webhook triggering, and it just outputs it into our log down here on the bottom. And then you'll notice up here, I just have a function URL and a GitHub secret that I can basically copy and paste into GitHub to wire up this function to run. And so if you haven't wired up a function to run, or a webhook to run inside GitHub, it's pretty easy to do. You just basically open up whatever repository you're working with, you click the settings button, and then on the left-hand side, there's this thing called webhooks. And all you need to do is you just click add webhook. You gotta make sure you're signed in. And then you basically just paste in a URL that you got from that function and the GitHub secret that you can get from your Azure function into there. And you wanna pick what format, make sure you're sending JSON if you're using the default template. And then you can basically just sort of say, what events do I want GitHub to tell me about and call my webhook when someone does something. So I could say anytime a new issue is opened, call my webhook running inside Azure and let me run some code in response to it. And in fact, that's what I've done here. If you look at this webhook that I've already wired up, is I basically have triggered it so that every time a new issue is created, it calls my Azure function. And just to prove that, I can go here, we'll go ahead and I'm just gonna say even more silence in Vegas. I'm going to post this comment in GitHub. When it happens, GitHub's going to call the webhook that was registered for issues. If I go back here and zoom in my Azure function, there I just outputted even more silence in Vegas. So GitHub passed the parameter in, my function spun up and executed. It was able to do any code it wanted to. In this case here, it just output it to the command log, or to the output log. And a simple, easy way now that I can integrate webhooks and use serverless, and I could have the world's most popular GitHub repository with millions of issues being raised, and I would probably pay less than 25 cents a month in terms of total costs to have that webhook running all the time, every time one of those issues was created. So super easy, cost-effective way you can do integration. Now what's nice is you can do this not just with webhooks, but I can trigger anything. So I could have a timer and say every 5 seconds run some code. Or I could go ahead and say every time something changes on the file system or the storage system, run some code. And so let me show you an example of that one here. So inside Azure, we have what's called the Azure Storage System, which lets you store, you can have literally 5 petabytes per storage account of content that you can upload. And it could be images, it could be files, it could be anything you want. What's nice with functions is you can now trigger so that, for example, every time something gets uploaded into that storage account, you can run code. And so this particular example here is just the sample storage trigger. It's just going to output the name and the file size of whatever file was uploaded into this particular blob account. And it's really easy for me to basically wire this up inside the Azure portal to point to any of those file or storage accounts I want to use. And so in this case here, I'm just pointing to a particular storage account I already have created. I could point to a queue, or I could point to a service bus, or I could point to any number of resources inside Azure. This one just happens to be pointing to a storage account. And what I can now do is just go into this File Storage Explorer, and I could go ahead and say, hello Vegas, on the file system and save a file. I could then go ahead and upload that file. Upload, this is using the Storage Explorer. It's sort of a GUI-based tool. It works on Windows, Mac, and Linux. It uploaded the file, and if we go back now into my browser, what I should see, if I copied it to the right folder, which I did, good, is that trigger just executed, and it said, hey, this file was just uploaded. And again, I can use that now to process the file asynchronously in the background, all with serverless code, and be able to execute it appropriately. And what's cool also about serverless is it runs not serially, it can actually run thousands or millions of events simultaneously. And so I could basically now use this so that if I uploaded files, and it might be millions of files that I'm uploading, I could run millions of different functions concurrently, all processing those files, all in the background, and scale it out. And again, if no files are being uploaded, nothing's being run, and I'm not having to pay anything. So again, nice elegant way that I can go ahead and scale up and scale down based on what I need. So let's look at a couple other scenarios. So I've been showing stuff now inside the browser. Let's switch gears and show it off inside Visual Studio. As I mentioned, we have rich Visual Studio support for doing serverless functions as well. And so I can just go ahead and say new Azure function inside Visual Studio to create an app using serverless app using VS. And I'm just going to go ahead and open up an existing project that I have to show off what that looks like. And so this is the back end to a very simple app that I'll show you in just a second. Actually, I'm going to show it to you now. That does what's called image moderation or cat moderation, since it's a cat review site. And I'm not, I have to confess, a cat person, but someone built this cool sample and I thought it was cool, so I thought I'd show it. This basically is a site that you can go ahead and review images of cats and upload pictures of your favorite pet. And what we want to do on this site, and we'll just go ahead and hit run here to show it off, is every time someone uploads a picture of a cat, is I want to verify that it really is a cat and that whatever text that the person enters is actually legitimate and does not contain any profanity. And so if I go ahead here and upload, let's say, a cat, and I'll just say cute cat. When I hit create, we're going to save that image up to the storage system. We're going to put something in a queue, and I want to basically go ahead and run some code here inside my Visual Studio project that basically reviews the image and verifies that it's a cat, and then also verifies the text is appropriate. And if it is, it'll approve it. And you'll notice here, it's a very simple function. Nice thing is it's running inside a VS project, so I can add any number of files I want. I'm not constrained to just a text box inside the browser. And I have full debugging support. And so in fact, what I'm going to do here is run this app locally on my laptop, and I'm connecting it up now to the cloud-based web app and the queue that web app is using, so that when someone posts something in the cloud, this function is actually going to run here. And in fact, someone has kindly in the audience, it looks like, already posted a picture. And you notice the picture says a squirrel standing on a rock. And I'm hoping it is a good picture. Please don't upload anything inappropriate. It's the danger of having a live demo. Let's inside now, cute cat. Let's post this one. And so basically, I just posted a cute cat. It now just posted up into the cloud. It's going to trigger this function to run. You can see here, a black cat sitting on a bed. There's more cat pictures. And so yeah, the beauty is we can process any number of images simultaneously, although it'd be great if you hold off on that just for a moment while I process my pictures, so I get through the demo. Anyway, and so we'll see my picture hopefully in a second. The beauty about the cloud is you can spin up millions of these things simultaneously. Now the downside is, remember, this is running locally on my laptop, so if you all spin up millions of pictures, it is actually going to take longer because I have a local debugger attached to my local system, and it might take a little longer for my picture apparently to come. And hopefully though, soon we will have there. In this case here, you'll actually see now my cute cat was actually, did pass. And it applied. You can see here that squirrel did not, which is good, as did that dog. And this is a cat and a mouse. So anyway, you can see that these are real, and we actually are filtering appropriately based on the picture here. So let's go ahead and just try one more here before you guys go to town and do some more pictures uploading, which is I'm just going to upload a dog, and I'm going to try to cheat the system and say, this is such a cute cat. Of course, it's not really a cat, it's a dog. And so when I go ahead and create, again, it's uploading it, it's sticking it in the queue. And what this is now going to go ahead and do is break into the debugger in just a second. And then let me explain what is actually happening when we were running that and what's going on there. This is another picture that someone else put, but that's okay. So the thing you'll notice here is, for this particular example, it looks like someone had a capture called a dog. Oh, I'm sorry. No, this is actually right. Never mind. Let me explain this. So what's actually happening here when we're calling this is this function is calling out to an API that's in Azure called Cognitive Service API, and it's doing image detection on the picture automatically. And so what's happening here is you'll notice it's returning back a description of what the picture has. And so in this case here, it's a dog looking at the camera is what this image detection API came back with. And this allows me to very quickly inside my code check to see, is there a cat in this description? If there's not, reject the picture. And this is all using AI and machine learning. And so I don't actually have to be an AI data scientist. Instead, I can just call this API. And so you'll notice here, in the debugger, does it contain a cat is false, even though the text, which says this is a cute cat, passes. And that literally, just a couple lines of code, I can now reject this particular picture. And now if you go back here and hit reviews, you'll notice it's not on the main website, but if I click on rejected, it's now in the reject folder because that didn't pass. And whoever tried to upload the squirrel picture from the audience, you'll notice your picture's in the rejected folder as well, because this came back as, no, this is a squirrel, this isn't a cat. And as a result, my application was able to automatically reject it. And so this is a nice example of, again, using serverless for review moderation, but also integrating with other services in Azure, in this case here, machine learning, to do automatic AI detection and, again, have a lot of fun. And the cool thing is this whole moderation app is, hosting the website, is about $5 a month. And then this whole serverless app and all the AI behind it is about 12 cents a month, assuming I don't have millions of pictures that get uploaded. And it's all running serverlessly. And so it ends up being incredibly cost effective in a way I can take advantage of. It looks like someone just uploaded another picture, so I'm going to stop the debugger before we get in trouble. So anyways, that's a little bit about serverless. We can go back to the slides now. Again, hopefully give you kind of a sense of what you can do with raw functions. The other thing that we then do have, it's kind of a cool demo I'll show as well, is something we call logic apps, which is another kind of, again, an example of one of these productive services that we try to build into Azure that enable you to actually run serverless logic without actually even having to have code that you have to write to do it. And so with a logic app, you can basically use built-in connectors that connect to different data services and different SaaS apps and be able to create declarative workflows that can execute in response to certain events happening. And so if we go back to machine A now, let me show you a demo of what that looks like. So no more cats. We're going to go back to the Azure portal here, and I'm going to take advantage and open up this logic app that I created earlier to kind of show off what this looks like. And so with the logic app, you can take advantage of a declarative designer we call the logic app designer. It runs both in the browser, it also runs inside Visual Studio as a project template. And the nice thing with this logic app designer is it allows me to take advantage of built-in connectors that Azure's already has to basically execute logic. And so this simple serverless workflow, unlike the webhook that we had from GitHub where GitHub was pushing, is actually going to talk to Twitter, and it's going to poll Twitter every 15 seconds and look for any tweets that have the hashtag Azure in them. And this is just a built-in connector that runs serverlessly. I'm then going to take advantage of, again, some more AI APIs. In this case here, to check the sentiment of each tweet that's being said about Azure and basically detect, is this thing negative or positive on a scale of 0 to 1. I'm going to extract out all the key phrases that people are talking about. So are they talking about VMs or app service or node or the portal and be able to pull that out. If I want to, I can call a serverless function that I can write JavaScript or C# or Java code to write some custom logic that I want to have as part of this workflow, so they integrate very cleanly together. And then what's nice is I'm going to take advantage of some more built-in connectors to basically push the results of all this logic into a Power BI data set that'll let me visualize all the tweets coming in. And then if it's a negative tweet, so in other words the sentiment is less than 0.3, I'm going to push it into a Teams room, which is like a Slack channel, and we also have a connector for Slack. And I'm going to open up a support case in Dynamics 365. I could also take advantage of a connector and point it to Salesforce instead. And the beauty is I'm doing all this declaratively without having to write code. And I can take advantage of all these built-in connectors that we have. And if I click Add Action here, you can see an example of just some of the other connectors that we have in the system. And we literally, Salesforce, Office, Dynamics, Box, Google, Facebook, Twitter, on-prem SAP, Oracle, SQL systems, and more can take advantage of them all built in. You can also build your own connectors and point to your own APIs inside your applications as well. And now that this thing is running, what I can do is, if I go up here, I'm going to launch a Power BI dashboard that I built. And let me warn you, this is Twitter, so I have no idea what we're going to see. But this is basically showing you now live, real-time feedback of everyone that's tweeting about Azure around the world. And so each of those dots on the right-hand side is a tweet that's coming in. And then up here, it's actually showing me this average sentiment of what people are tweeting about. And so the good news is people are pretty happy, which is good. And 0.5 is neutral. So basically, it looks like most things are neutral or higher. And then I can also sort of see what are the different Azure hair. I don't know what that means, but someone tweeted about it. Again, it's real. What are the key words that people are tweeting about? So anyway, this gives me a way I can kind of monitor what people are saying. And then the beauty is, again, if anything is negative, if you remember, we're dumping it into a Microsoft Teams room so that everyone on my team can basically see it within our channel. And can jump on it if it's a negative tweet. And again, this is also real, so we'll see what they say and apologize if they say anything inappropriate. But this, there we go. This is seriously fun. This guy now has the Azure plus F# bug. And I think the sentiment analysis said bug sounds like a bad thing, and so flagged it as possibly negative. In this case here, thankfully it's positive. But now I can actually, I'm using AI to see all these things. My team can basically see it, and then I can automatically open up a support case for anyone that says anything negative. The beauty about all this, again, is it's running serverlessly. I don't have to have VMs stood up. I don't have to write a bunch of complex integration code. I'm just taking advantage of the built-in connectors that are provided from this. And then I can go ahead and monitor all the traffic that people are doing. And so this is all of the tweets that are flowing through the system. If I click on any of them, I can even debug after the fact, how did the logic app run? And so this is a tweet that someone said, what did they say? Scroll down. Azure Security Center is now included in Azure SOC 1 and SOC 2 attestations. So it's a compliance-related tweet. You see the sentiment came back as positive, so 0.95, so they liked it. We pulled out the keywords, we pushed it into the data set, into the Power BI dashboard, and then because it's positive, it ended. It didn't actually open up a support ticket or push it into Teams. So a simple way I can debug after the fact what's actually happening and seeing all these automated serverless workflows run. Again, super easy way to stand these things up, integrate across data that's running in the cloud, running on premises, running with existing systems or in other cloud providers, all running serverlessly, all in a super productive way. So we go back to slides. Let's maybe talk about one more service in the remaining time. So the challenge, talking about Azure is we have literally 100+ services now that you can take advantage of, and it gives you sort of the power and flexibility to really do everything and anything that you want as you're building systems. And so what I do is just close on showing off a couple more new services that we've recently launched that you might want to take advantage of, in particular when dealing with data. So the cool thing about Azure is we have built in what we call data as a service options. So we have SQL database as a service, we have Postgres database as a service, we have MySQL database as a service. And those give you kind of a relational database service that you can take advantage of where, again, like you saw with these other services I demoed, you don't have to manage VMs yourself. They're instead provided with an SLA and a whole bunch of these built-in capabilities that you can leverage as part of building your applications. We also just launched a new service recently that we call Cosmos DB, which is kind of a special type of data service that gives you the ability to really deliver data at what we call planet scale. What do I mean by that? Well, the nice thing about Cosmos DB is it doesn't just run in a particular region in Azure. It can actually run all over the world, and it can basically store and handle any type of data and be able to let you build applications that can go to extreme levels of scale and sophistication and really do some cool stuff with it. So as I mentioned, it can run all over the world, and more importantly, it can run all over the world simultaneously. And so if you're building a system here in the US, you might want to have a version running in the East Coast of the US, the central part of the US, and the West Coast of the US, and be able to send your users automatically to whichever version is closest. And that way, if you're a retailer, you have lightning fast performance, and you can literally load your site up in literally just milliseconds of response time. And the beauty about Cosmos is it lets you do that, where you can literally replicate the data in real time across all the regions around the world, and anywhere that you want to be able to kind of basically host and run your applications. It's designed to be able to store any type of data. So you can store relational data inside it, you can store key value pairs, you can store documents, you can also store graphs of data all within the system. And it has a variety of different APIs that you can use to program against it. So we have a Mongo API, we have a SQL API, we have a Spark API, and we have a Gremlin Graph API if you're, for example, doing graph-based access. It's designed to scale to any need. So you can literally start with a couple gigabytes of data and then scale up to be petabytes of data if you need it. And again, you pay only for what you use and what you provision. You can also start with, say, a couple hundred transactions per second, and if you want to, scale it up to 10 million transactions per second as part of the system, and get guaranteed capacity that lets you scale to that level. And what's nice is it gives you SLAs around all these things, not just availability, but performance and latency as part of the system. In fact, our latency guarantee is that all of your requests will complete in under 10 milliseconds, or you get your money back. And so this basically gives you kind of the ability to build apps that you know are going to be fast, that are available everywhere, that can handle any type of data, and can scale to just enormous scenarios. An example of one of the customers of ours here in the US that's taking advantage of it would be Jet.com, which is now part of Walmart. They were a startup that started on Azure. They were bought about 18 months after they launched for $2.5 billion. So it was a very successful startup. And now they're driving a lot of the e-commerce work that Walmart's driving across their business. And they run on Azure. And for Black Friday, which was a year ago, they scaled up their Cosmos DB database across 3 regions in the US, since they're a US-based company. And they configured it just to be able to process 100 trillion transactions that day. And they saw single-digit performance at the 99th percentile over the entire day. No other database platform out there can give you that type of performance and that type of scale. And what's cool is it's really easy to take advantage of, and you can build some cool stuff with it. So let's go ahead and switch now to machine B and do one last demo here that shows off how you can build it. So I'm going to go ahead and run an app. So let me just get back here. On my system. And let me show you the app that's running. And so this is a simple like Wikipedia-like app that we'll demo. The difference here between standard Wikipedia and this one is instead of being a Wikipedia about everyone in the world, this is a Wikipedia about Marvel Comics. How many people here like Marvel Comics? Great. It's usually easy at a developer event to get lots of hands there. I find at financial analyst events, it's not as easy to get hands go up on it. But anyway, so a simple app here. And this is showing obviously lots of content. Ignore the static content. That's not that interesting. But it's being pulled from the database. And then it also has this sort of chat bot that's integrated here on the right-hand side, where I can go ahead and ask questions of, in this case here, I'm on Tony Stark's page. So I could ask, for example, who are your friends? And it does a query and brings back, who are the list of friends of Tony Stark? And if I want to, I could also say, okay, who are your, let's say, your enemies that work for Hydra? And if I hit enter, it brings back, Tony Stark's enemies who work for Hydra. And what's interesting about kind of a chat or bot-like experience like this is the types of questions I might ask can be pretty rich. And so when you start doing things like, who are your friends? You can imagine how in a relational model, foreign key, primary key, that's not that difficult. When you start saying, who are your friends that also are friends with so-and-so or work for so-and-so, you start to actually have to write deeper and richer types of queries, ones that aren't always well suited for a relational model. And in fact, if you look at most social network sites, like a Facebook or so, they have a notion of a graph, because graphs are much easier to represent relationships across lots of people than a traditional relational model. And what's nice about Cosmos DB is when I create a Cosmos DB, if I want to, I can store graph data in it. And in fact, that's what we did inside this application. And so what I did here is I could create a new Cosmos DB app pretty easily. I just go a new Cosmos DB, and this would create a new database. When I create that database, if I want to, I can specify, I've somehow managed to, there we go. I can specify what type of API I want to create. And so you can see here, one of the options is I could go ahead and say I want the default experience to be a graph API as part of it, and I can choose where I want to initially run this in the world. In this case here, I already have a database loaded, just in the interest of time. So let me load that up here. And this is, again, a Cosmos DB database that has graph data already loaded in it. If I want to, I can even go ahead and open up what that graph data looks like. And the Azure portal experience for Cosmos DB gives me kind of a nice experience to look at it. I'm just going to go ahead and write what's called a gremlin query. So this is what this G-V thing looks like. And this is now querying the data in this Cosmos DB database and bringing back all of this graph information. So let's, oops. Zoom in a little bit here. And you can see this is an example of that Marvel character data represented. Now, right now there's GUIDs. Let's go ahead and style this. And I'm just going to go ahead and say, let's show the name instead of the ID. That makes it a tiny bit easier to see. And you can now start to see all these items that are inside this graph database, how they all interact, and how all the characters are related to each other. And again, it's all represented in this sort of graph data model that I can now query. And I could query it, obviously, using the portal here and just type in custom queries. Or another way I could do it is do it programmatically from code. And in this case here, I'm just querying it. In this case here, this is a Node.js app again. And I'm just imported the standard Gremlin library that comes from NPM. There's one for .NET, Java, Python, Ruby as well. And then I can basically just write queries, again, in whatever language of choice I want with this Gremlin query graph syntax and bring back those results. So again, easy way I can stand it up, I can load the data, I can manage the data, and I can now query it. Now what's powerful though about Cosmos is not just that it's easy to use and that I can query a graph, but it's really that I can run this thing globally and I can do it at enormous scale. And so if I click on this replicate data globally map, you can see here all of the different places that this particular Cosmos database is now deployed. So you notice I got a couple in the US, I've got one in Europe, I've got one in India, I've got two in Australia, I've got one in Singapore, and I've got one in Japan. And if I want to run this, for example, in Korea, or actually that's in Korea, if I want to run it in Japan or Korea, I can just go ahead and click on a particular item here and hit save, and then Azure will automatically replicate my data to Korea, and I can now have an instance of this app in Korea be able to, again, have single-digit millisecond response time against this query of data. So super easy way that I can scale it out. We also support built into Cosmos DB a notion of what we call consistency. And so a challenge you might have when you start rolling and deploying your data all over the world is if I save a transaction here in the US, when does it show up in Australia? And what kind of guarantee do I have that the transaction data has been written everywhere before it completes? And so that's a challenge to distributed systems in general. And so the nice thing with Cosmos DB is we give you the option to control different consistency models. So you can have strong consistency, which means every time you write a transaction, the data is guaranteed to be everywhere else once it completes. You can have what's called eventual consistency, which means your performance is faster. And so you write a transaction, it's guaranteed to be complete in that region, and then it'll eventually replicate everywhere else around the world. That's great for, say, content that you're updating, so you're not blocking the transaction as it rolls out worldwide. And we also have things like session consistency, which is a nice compromise between the two, which means that if I write the transaction data and then I immediately read it back, I'm guaranteed to always see the results I just wrote, but I'm not blocking the transaction and requiring it to be replicated everywhere. The beauty is you have the control with Cosmos to configure this, both the default as well as on a per transaction level, which gives you kind of maximum flexibility and the ability to have performance that just screams everywhere. And then last but not least, once you go ahead and run your application, you basically at any time look at your metrics and we'll show you whether we're meeting all those SLAs, again around availability, around performance latency, around the number of requests per second that you can process, as well as overall runtime performance. And no other database out there gives you everything I just showed you at that global scale with all that flexibility and with that guaranteed performance. Again, that makes it much, much easier for you now to build applications and be able to run them anywhere around the world. So we go back to the slides real quick. We'll go ahead and wrap up. I've shown you lots of different services that we have inside Azure that you can take advantage of. And I've been building them in many cases just directly from my laptop inside the IDE. You can also very easily, using our Visual Studio Team services, easily wire up your environment for a full continuous integration, continuous deployment style model and do everything completely automated. I know there's some great talks here at the conference where you can go into detail on that. And this gives you, again, the power of the cloud, but also a phenomenal development experience that you can use across a team environment and enable really powerful development. And I've only scratched the surface of the types of services that we have inside Azure, whether it's IoT, whether it's data warehousing, whether it's around AI, which I think Steve Guggenheimer is going to talk about in the keynote tomorrow, whether it's around high performance computing and a lot more. There's just a tremendous number of these services that have the core promise that I talked about at the beginning of being productive, enabling you to work in a hybrid environment, having intelligence built in, and being trusted and secure. That's going to enable you to build phenomenal applications. And I'm really looking forward to seeing, hopefully, you trying out the cloud and what you build with it. If you haven't tried out Azure before and you're interested in it, if we can go back one more time just real quick to Machine A. The best way to get started, if you go back to Machine A, is check out the azure.com website. And if you click Start Free, you can sign up for a free trial. This includes $200 of free credits that you can use across all the services I just showed here this morning. and gives you a kind of no obligation, no payment way to try things out. The other thing we now have that's pretty cool is a 12-month offer as well, so that once your trial ends and you've used up those $200 of credits, we give you an additional year of free services that you can also take advantage of and use. And that includes, for example, VMs. And so you can run a Linux VM or a Windows VM for an entire year for free and play around. You can build app services. You can launch SQL databases. You can use Cosmos DB, serverless functions, and more. And this gives you, again, another way for a whole year that you get a chance to kind of play around with what the cloud has to offer and take advantage of a bunch of free capabilities. And if you're an MSDN customer, sign up to Azure using your MSDN login and password, and we'll give you up to $150 a month of credits every month that your MSDN subscription is active, and you can apply those again also on any of these services from a dev test perspective. So if we go back to the slides, hopefully what you saw here in some of these demos, were some of these characteristics of productive, hybrid, intelligent, trusted. Hopefully as you start using Azure, you'll see these on a daily basis as well. And I'm really looking forward to seeing what you build with the cloud, and I wish you all the best of success. Thanks so much for coming to the conference, and I hope you have a great week.